Hello, good day. This is Dr. Ligardo Arpalaca Jr. once again. And for today's lesson, I will be presenting and discussing a topic which is somewhat overpowering to some people who is not fun or who is not so oriented with numbers, with statistics. But, just journey with me because I am one of those people who is not into numbers, but I would tell you, we cannot get away with numbers when I took the SESW exam. By the way, thank you so much for all your greetings now. So I passed the SESW exam and I am ranked as third among the the passers for the whole nation. It's a nationwide examination, so I am so thankful for you. And a major part of of that examination, the battery examination conducted by CESO, is the CESB board. CESB board is on statistics and data interpretation. So it is something that is present in almost all government and non-government organizations. So we like it or not, as students, as graduate school students, you really have to take a research subject which involves statistics as well, and subject or a course on statistics. So our lesson for today is all about understanding ways to collect data in a simplified manner. Okay, so our first lesson is all about determining sample size. So in research, it is somewhat expensive and time consuming if our if we will conduct our research, especially if it's a survey to the population, because it would involves thousands of people. So given our limitations in time, in budget, and in manpower, so we have to take a sample or a representative of the population. So we call it sample. So population the um, is the total number of individuals, animals, items, objects, or whatever any given subject being investigated. And portion of that is what we call a sample. So if you get a number of respondents or a number of object from the group, so we call it a sample. So population is the measurable quality is called a parameter. So we have a parameter. That's why I mentioned other than people, I mentioned animals or any given subject of your research. So the population is a complete set. So research with a population, as a respondent, really would provide us with a conclusion, because it's not a representation of opinion, but it's really the uh, actual report from the respondents, not just a representative. However, because when you conduct a research with the population as your respondents, it offers, or you will experience lots of challenges. So in terms of time constraint, money, and other resources in conducting your research. That's why researchers would like to get portion of that population. So that's what we call a sample. So the measurable quality is called statistics. So there is a formula to identify, or to really to calculate the acceptable representative of the population. So the sample is a subset of the population, and you know actual reports have a margin of error and confidence interval. So there is a margin of error. It is admitting that there is a possible error in the identification. That's why we allot a margin of error, and it is a subset that represents the entire population. Okay, so what is being presented here is the illustration on the difference between a population and sample. So we have here in our population, we have 15, 1, 2, 3, 4, 5. So it's 15, I think. Now, so if 15 represents like 100, so you have like 1,500 population people as your population as your possible respondents. So you will just simply get uh 500 out of the 1,500. So your sample is 500 out of 1,500. So sample used by researchers should closely resemble the population. All the participants in the sample should share the same characteristics and qualities. So if the study is about male college freshmen, the sample should be a small percentage of males that fit this description. Similarly, if if the research conducted is on the sleep patterns of single women over 50 to 70, the sample should only include women within this demographic. So it should not be women above 80 or 7 or above below 20 because they are not part of the criteria that you use in the identification of your sample. So when you conduct a research about a group of people, it's rarely possible to collect data from every person in that group. Instead, you select a sample. So the sample is the group of individuals who will participate in the research. So to draw a valid conclusion from your results, you must carefully decide how you will select a sample that is a representative of the group. So these are two types of sampling methods. So first is the probability sampling methods, this one. The second one is the non-probability methods. So there are also examples of methods under this category. So the probability sampling involves random selection, allowing you to make statistical inferences about the whole group. So you will be using a formula on the identification of your sample. While the non-probability sampling methods involves a non-random selection based on convenience or other criteria, allowing you to easily collect initial data. So this is more of giving convenience to the researcher. Whereas here in the probability sampling methods, because this involved involves a computation of your possible sample size and the identification, a strict identification of your sample because you would provide a criteria. Okay. So you should clearly explain in your research, you should clearly explain how you selected your sample in the methodology section of your paper or your thesis. So it is very important that you would provide an explanation and the steps involved in the selection of your samples because it matters a lot because as I mentioned, uh, you should be clear and valid in the selection of your sample because this would affect the outcome of your research because the sampling methodology would affect the result of your study. So your conclusion and your recommendations, which are very important parts of your research, would be affected. Okay. Okay, so imagine you have a population of 100 people in your organization. In this scenario, every person would have odds of 1 in 1,000 for getting selected. So probability sampling gives you the best chance to create a sample representative of the population. So this sampling allows for unbiased and representative conclusions to be drawn about the population based on the sample. Okay, so take note of the words unbiased and representative conclusion. So you must be careful in the selection of your sample because it would affect the result of your study. It would affect the conclusion of your study. So probability sampling is a technique in which the researcher chooses samples from a larger population, using a method based on probability theory. For a participant to be considered as a probability sample, he or she must be selected using a random selection. The most critical requirement of probability sampling is that everyone in your population has a known and equal chance of getting selected. So probability sampling uses statistical theory to randomly select a small group of people we call a sample from an existing large population and then predict that all the responses will match the overall population. So the first type of the probability sampling method is the simple random sampling. So simple random sampling is a subset of statistical population in which each member of the subset has an equal probability of being chosen and is meant to be an unbiased representation of a group. So for example, you have like um, 150 uh, possible respondents. So we call it a population. So you will get um, 50 people as your sample. So first is you have to make a list. Now you have to make a list and then you write the names of your respondents, possible respondents, and then you have to assign a sequential number like respondent 1 would be number 1 and then you have to choose a sample size based on a statistical tool that you have to employ. And the fourth one is use random number generator. So we have many apps in the internet that would do this one. But if the app is not available, so simply you just put the name of the your respondents, not your the total population, the population in a box, and you have to select 50. You have to mix the names, and then you have to select 50 names out of the 150 names. So by that way, you are now able to select your 50 respondents uh, out of the 150 people as your population. So as simple as that. So the second example is the systematic sampling, which is actually similar to the simple random sampling. However, systematic sampling is slightly easier to conduct. So here, every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals. For example, all employees of the company are listed in alphabetical order. So from the first 10 numbers, you are randomly selecting a starting point. Like for instance, number 6. So from number 6 onwards, every 10th person on the list is selected. So you have like from 6, so next would be 16, 26, 36, and so on. And you end up with a sample of 100 people. So it's not only limited with 6. You may use another number as your starting point. So if you use this technique, it is important to make sure that there is no hidden pattern in the list that might skew the sample. So for example, if the HR database groups employees by team and team members are listed in order of seniority, there is a risk that your interval might skip over people in junior rules, resulting in sample that is skewed towards the senior employees. So something like that. So you also have to minimize possible occurrence of biases. So the third sampling technique is the stratified sampling. So stratified sampling involves dividing the population into subpopulation or subgroups that may differ in important ways. So here, this sampling allows you to draw more precise conclusions by ensuring that every subgroups is properly represented in the sample. So to use the sampling method, you divide the population into subgroups called strata based on the relevant characteristics like gender, age, uh, income bracket, job role, and others. So based on the overall proportion of the population, you calculate how many people should be sampled from each group. Then you use random or systematic sampling to select a sample from each subgroup. So, for instance, the company has 800 female employees and 200 male employees. So, you want to ensure that the sample reflects the gender balance of the company. So 20%, 80% and 20%. So you sort out the population into two strata based on gender. So then you use random sampling on each group, selecting 80 women and 20 men, which gives you a representative sample of 100 people. So the fourth sampling under this method is the cluster sampling. So as illustrated in the drawing there in the caricature. So cluster sampling involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. So instead of sampling individuals from each group, you randomly select entire subgroups. If it is practically possible, you might include every individual from each sampled cluster. So if the cluster themselves are large, you can also sample individuals from within its group using one of the techniques. So this method is good for dealing with large and dispersed population, but there is more risk of error in the sample as there could be a substantial difference between clusters. It's difficult to guarantee that the sampled clusters are representative of the whole population. So, for example, if the company has offices in 10 different cities across the country, roughly with the same number of employees in similar roles and responsibilities, you don't have the capacity to travel to every office to collect your data. So you use random sampling to select three offices. So out of the 10 cities, you only selected um, three offices. So according to experts, in the cluster sampling, no, since um, you accepted the fact that you have limitations to gather or to select all possible respondents with the diverse and dispersed populations that you have. Now, so you have to divide the population to clusters and select particular cluster. And second is if the selected clusters is too large, you may also um, create um, a cluster out of the cluster, something like that. So let's go now to the non-probability sampling methods. So in non-probability sample, individuals are selected based on non-random criteria, and not every individual has a chance of being included. So this type of sample is easier and cheaper to access, but it has higher risk of sampling bias, and you can't use it to make valid statistical inferences about the whole population. So non-probability sampling techniques are often appropriate for exploratory and qualitative research. So in these types of research, the aim is not to test hypotheses about a broad population, but to develop an initial understanding of a small or under-researched population. So let's talk about convenience sampling. So a convenience sample simply includes the individuals who happen to be the most accessible to the researcher. So for practical reason, this is an easy and inexpensive way to gather initial data, but there is no way to tell if the sample is representative of the population, so it can produce generalizable results. So, for instance, your statistician told you to have like 100 respondents. So, your using convenient sampling, so you simply stayed in a place, like for instance in your school, and the first 100 people to pass by will be your respondent. So your student A, na? So student A passes by, so you simply ask that student, hey, hi, um, you are selected to be a respondent of my research. Na? So every person that will pass by on that particular day now will be your respondents till the number would reach 100. So as simple as that. So let's go now to the voluntary response sampling. So similar to convenience sample, a voluntary response sample is mainly based on ease of access. So instead of the researcher choosing participants and directly contacting them, people volunteer themselves by responding to a public online survey. So I'm sure you experience this one, not necessarily answering, but you open certain websites. And then there is a pool, there is a survey there. It is a voluntary. However, you should be careful because if a survey asks for your email address, bank accounts, or other pertinent personal information, you should stop answering those websites, those survey, and also you have to block those websites because it is an example of a phishing predatory websites. So voluntary response samples are always at least somewhat biased, as some people will inherently be more likely to volunteer than others. So example here is you send out survey to all students at your school and lot of students decide to complete it. This can certainly give you some insights into the topic, but the people who responded are more likely to be those who have a strong opinions about the topic. So you can't be sure that their opinions are representative of all students. So that is an example of a voluntary response sampling. So let us focus your attention. Please focus your attention to purposive sampling. So this type of sampling involves the researcher or researchers using their judgment to select a sample that is most useful to the purposes of the research. So it is often used in qualitative research where the researcher wants to gain detailed knowledge about a specific phenomenon rather than make statistical inferences. So, an effective purposive sample must have clear criteria and rationale for inclusion. That means that you have to explain and provide qualifying characteristic of your sample so that you will be able to target the person that you would like to interview or you would like to answer or to join your research. So example here, so you want to know more about the opinions and experiences of disabled students at your school. So you purposely select a number of students with different support needs in order to gather a varied range of data on their experiences with the student services. So something like that. It is clear here that in purposive sampling, you have to clearly define the characteristic of your respondents. So the last one is the snowball sampling. So here, if the population is hard to access, snowball sampling can be used. to recruit participants via other participants. For example, here, this is your original participant. He was able to recruit two, and these two um, participants were able to recruit three. Now, so it will be Y then, according to the number of respondents you need. So first is you have to identify really the most influential, the most known respondent that possibly can connect you or can recommend you to other respondents like a snowball. Now you start with one a group of uh what a snow, then you have to make a ball and then you add more till it will become like a snowball. So you are research example here. So you are researching experiences of homelessness in your city. Since there is no list of all homeless people in the city, probability something isn't possible, di ba? So here you look for one person who agrees to participate in the research, and then as he puts you in contact with other homeless people that she knows in the area. So with that, you are connected to a wider um, number or a bigger number of participants to answer your question about homelessness, experiences of homeless people in your city. So that's it, my dear students. So I hope that by this simple explanation and concurrent example of the different sampling technique, it will help you with your research in the future. So thank you so much. Uh, Bye for now, and thank you for listening.